Ladies and gentlemen, to discuss robotics in the AI era, its challenges and its opportunities, please welcome to the stage Torsten Kroeger, Chief Science Officer at Intrinsic, Brendan Schulman, Vice President at Policy and Government Relations at Boston Dynamics, and Damion Shelton, co-founder of Agility Robotics. The conversation will be moderated by Ira Moskowitz, CEO of the ARM Institute.
Good afternoon, I'm Ira Moskowitz, the CEO of the Advanced Robotics for Manufacturing Institute, or ARM Institute. And I want to thank SCSP for the honor of moderating this very distinguished panel next to me. I'd like to start by setting the stage of why AI and robotics is so important. The Advanced Robotics for Manufacturing ARM Institute is a national public-private partnership. We are partnered with the Department of Defense, and our mission is to advance the modernization of the defense industrial base and the organic industrial base through automation and robotics. We're a member-based consortium of over 460 members that represent many of the leaders across industry, academia, and government in robotics and automation. When we were founded 8 years ago, our experts decided that there were 5 areas of robotics that had to be advanced, one of which was the intelligence of robots, or AI and robotics. 8 years later today, almost everything we do is either focused directly on AI and robotics or is enabled by AI and robotics. In addition, at the end of last year, we did our annual survey of our members, and we asked them what is the #1 most important topic that they need the ARM Institute to focus on. And almost unanimously, it's AI and robotics. So I wanted to share those facts because I'm asserting that this topic, the AI in robotics, is the most important topic today in robotics and automation. And we're honored to have these very distinguished experts with us to talk to you about that. I'd like to take a minute to introduce them. I know not all the panels introduce the speakers in detail, but I do want to make sure you know who's up here. I'm going to start with Torsten. Professor and Dr. Torsten Kroeger is the Chief Science Officer at Intrinsic. He's a serial entrepreneur with a proven track record in robotics and AI software innovation. He's founded multiple successful companies in this field. He led a robotic software division at Google. He was a professor at Karlsruhe Institute of Technology. He's consulted with major players like Volkswagen and Google, and holds numerous prestigious awards in this field from IEEE. So Torsten, thank you for joining us today. Next is Brendan Schulman. Brendan is the Vice President of Policy and Government Relations for Boston Dynamics. In this role, he collaborates with policymakers and stakeholders on a wide range of policy and ethics issues related to the integration of beneficial robotics into society. Previously, he was a leader prominently on the development of regulations and of legislation and safety issues for commercial drones, both here locally and internationally. He's on numerous advisory committees across the nation. He's testified in front of the US Congress and in fact in the UK for the House of Commons on these topics. And then finally, Damion Shelton is the co-founder of Agility Robotics. He's a multifaceted roboticist focused on building automation solutions that solve real-world problems, especially logistics and warehouse solutions. He previously served as CEO of Agility, and prior to co-founding Agility, he co-founded 3 Rivers 3D, where he served as CTO and designer of many innovative systems. So Damion, thanks very much for joining us as well. I would like to ask you just to set the scene, to start with a very high-level question, just to sort of give our audience kind of the lay of the land on this topic of robotics in this AI era. And so I'm going to ask each of you to respond to the following question. How is the integration of advanced AI capabilities into robotics enabling or redefining what robots can do, both socially and technically? And what does this mean for the future of safety and of labor and of automation itself? So Torsten, I'm going to start with you.
Sure. Thank you, first of all, for having all of us here. It's a pleasure, it's a privilege to be here on stage. So thank you all for your time. Let's start with AI and robotics. Like, when you compare what's happening in the physical world to what's happening in the digital world, we have a number of more challenges to deal with here, and I'm sure that my fellow panelists very much agree with that, because the physical world is just messy. Whereas in the digital world, like we can assume very often that we have perfect models, and data generation, for example, becomes much, much easier. Now, from as Intrinsic, we are looking at the manufacturing space, bringing AI and software into the manufacturing sector. And from a customer's perspective, we're looking at flexibility and cost. So if you give me an unlimited budget, I can pretty much automate any task you want me to, but no customer would spend that money because it's just far too expensive. And very often it's far too inflexible. Let's say I implement a very robust solution for, let's say, an assembly task, and you want to change it because your product has changed, you would need to, again, pay me like a lot of money in order to change it. So it's very inflexible. And now what AI brings to the table is that we can give robots a sense of vision, a sense of touch, and if you now can, for example, instead of programming a vision application, you just show the robot a part. Hey, this is the part that I want you to recognize. No programming required. And when you tell the robot to move from A to B, collision-free, as fast as possible, no programming required. This is where the flexibility comes in. And now suddenly, you do not necessarily need the PhD level expert anymore to program these systems. And this is what AI brings to the table. These are a few examples of what AI brings to the table in robotics and manufacturing.
Thank you, Torsten. Brandon, same question. How do the integration of these capabilities into robotics redefine robotics, and what does it mean?
Yeah, thank you. Great to be here. Thank you all for coming. A lot of you know us from just like the dance videos with the robots, and you might know that we've been around for over 30 years, so we're not like the startup. We were founded at MIT, and a lot of what you see in the Spot robot, for example, if you went to our booth or you saw my demo an hour ago, really that's the result of deterministic programming, figuring out how to get robots to take steps in a way that keep them upright, that keep them balanced. That was decades of painstaking work. I think what AI is doing is really breaking that model and also revolutionizing the space, the robotic space in amazing ways. So all this interest you've seen recently in humanoids and all the funding that's gone to startups is really, I think, recognition that robots, the hardware, the machine can be powered by AI. So you take a machine that used to be deterministically programmed, and now you do reinforcement learning, and you could basically catch up to our 30 years of work in about 30 months. So what is that doing? That's making the robots better and safer, right? We've got robots that now, for example, can learn to walk across slippery or icy floors in a more stable way. Why? We're doing reinforcement learning on it and getting the robot to train itself, something that we really maybe couldn't do the old-fashioned way. But we're also seeing an acceleration in the competition. Because now you can use AI on that kind of off-the-shelf hardware, we've got emerging competition from overseas, which is, I think, relevant to the national competitiveness questions here at the Expo. So particularly China, you've got competitors who have entered the space fairly recently and are catching up in capabilities because they're using reinforcement learning to create a robot that may not be as good as the kind you might have developed over 30 years, but might be good enough or closing the gap. But you've also got the promise of applications that can be accelerated through that reinforcement learning, computer vision, to get, for example, the humanoids to do things like automotive manufacturing. So acceleration, but heating up competition, and that's really driving the interest and the funding in this space right now, is that convergence of AI.
Thanks, Brandon. Damion, same question.
Yeah, so we are not quite as old as Boston Dynamics, but have a similar legacy of being rooted in the physical world. And I agree with everything that was actually just said. What we've seen in the last 10 years since we first started the company is really an evolution away from these purely dynamics-based models that really govern the ground contact. So if I sit the water bottle down, there is obviously physics that dominates that interaction as opposed to that being a computer science problem. When we had started Agility, we didn't have any way of layering the higher level cognition onto that system. We could figure out how to set the water bottle down. We couldn't decide why you might want to do that. So there was always this cognitive layer that we kind of pitched to our investors as an exercise for the reader, we assumed it would happen either somehow or that it would be unnecessary in the kinds of spaces that we were in. For instance, if you think about a warehouse automation task, you don't necessarily need a cognitive layer for that in the same way that you need for an AGI-based humanoid interacting with the real world systems. So it was very surprising to us 2 years ago when we first hooked up, at the time, ChatGPT 3.5 to Digit, our humanoid, using just the programming API of the robot. That worked amazingly well, and we think it worked well because it used a language like Construct, which was our software API, to connect to a system, ChatGPT, which was very good at manipulating language. And I think that suggests why this is a very exciting time to be in robotics, is you can actually leverage all of the systems that exist today and the existing programming APIs for them with these higher order models while the RL systems that Brendan were mentioning were coming online. I would say purely from a safety standpoint, maintain a healthy skepticism of RL, because black boxes are a little bit worrying when you have to meet safety and regulatory requirements. They're also worrying when you have foreign adversaries who may have different priorities for their black box than you do. But suffice it to say, it's a very interesting time to be in robotics.
Yeah, thanks, Damion. Thanks all of you for those opening comments. What I'd like to do now is dive a little deeper on a few questions, and I'm going to ask each of you a question based on your expertise and background, but ask the others to join in afterwards. So I want to start with you, Torsten. As the Chief Science Officer at Intrinsic, how are you addressing this dual challenge of enabling highly capable AI robotics while at the same time ensuring that they remain secure and reliable and safe in a completely open environment?
So let's maybe go back to the basics for a moment. If you think of an AI model, like a machine learning model, it is, by definition, it's a probabilistic model. And there's nothing we can do about it, right? Like the nature of AI is probabilistic. All of the machine learning models have a statistical background. Now, if you now think of things like safety, for example, and I think this is true in all cases, like for humanoids as well as for robots in the manufacturing industry, now getting to a level of robustness and reliability of 99 point, and now we can debate how many nines we want to have. In some use cases, we are getting to the point that these models, like in perception first and foremost, meet these industrial grade standards. So these models, we can statistically prove that these models are good enough that we can deploy them in the industry. Not in all use cases, like manipulation remains a challenge, but for everything that doesn't require a lot of physics, that's working very well already. And this is true for perception, grasp planning, motion planning, task planning, which is a great progress. It's really an enabling technology. Now, when it comes to training these models, you obviously need data. And in some cases, we can provide this data from our side, from Intrinsic, but in many, many cases, it's actually the customers providing the data. And this is where security plays a significant role. So, for example, we have the opportunity to work with Google Cloud to leverage those tools to make sure that the data that we get from customers is really secure. And it's a matter of trust, right? Like the customers need to trust us with their data, and this can be highly sensitive information. So when it now comes to training these AI models with customer data, it needs to be very clear to the customer what happens with the data, making sure that the customer feels comfortable sharing that data, but then also in return, customers see a benefit. For example, when using customer data to train a post estimator, the level of robustness and performance goes up. When taking customer data to train a motion planner, performance, cycle time go up. So it's giving and taking. So it's not that the data that customers provide goes into the void. There's a benefit to the customer, but communicating that to the customer and making sure that the customer understands, okay, this is giving and taking and the data is secure, is going to be crucial and paramount.
Yeah, and securing data is not new to many industries. I mean, I came out of the semiconductor industry, and you may be familiar with the foundry model, where companies around the world send a semiconductor foundry their data, which is their design, which is their entire IP, is in those data sets. It is sent to a wafer fab foundry, And over time, the years have developed these extremely secure systems, and there's a level of trust that goes back and forth. Your data will not be exposed to all your competitors that are making chips where if they got that data, you'd go out of business. So this problem is real, but it's been solved in many other industries as well. Damion or Brendan, any comments on this question of how do you keep all this secure and reliable?
Yeah, well, a comment on the data point, which maybe it's a subtle one, but I think important. When you think of all the AI technologies we tend to talk about a lot, image generation, text generation, a lot of the stuff in the exhibit hall here that's not robotics, think about where the data sets are coming from that underlie those AI tools, the AI models. It's the internet, right? It's the videos that are out there, it's books, it's articles, it's Reddit, it's Twitter. That's a huge amount of data that already exists and that can be used to enable the AI to create poetry and essays and images and videos, right? So it's just there. There is no corresponding set of robotics AI data. It doesn't exist out there. So we need to generate it. To some extent, you might be able to do it in simulation, but the real world is really the best. And that means that to be successful in the convergence of AI and robotics, we need more data, which means you have to go out and create it. So if you want, you've probably seen these videos of robots folding shirts 200 times, and then you have a robot that can do a pretty good job of folding a shirt on its own once it sees the shirt. You have to actually train it. And that's where we get into the competitiveness issues, right? If you want to deploy robots successfully from the United States, from allied countries, you need the robots to be deployed in industry and be used to generate the customer data that then improves the robots. We are not really doing that in the United States, right? According to ITIF, the think tank, robots are being deployed in China in manufacturing at a rate that's 12 times the rate in the United States. And so if we don't automate and have the robots out there doing things, we're not going to generate the data to make them even better in the next innovation cycle. So really important, in addition to the cybersecurity issues, are just the need for that data to be generated.
Yeah, I mean, something to add to that too that might not be obvious is that there's a very serious bootstrapping problem. And I have a very humanoid viewpoint from this just because of our history, but it exists for all robots. And specifically to highlight what Brendan said, if you don't have a way of getting a robot into a location and doing something useful for it, you create a chicken and egg problem, where first off, the robot's not doing anything useful, but now you also have no way to bootstrap yourself into the next layer. At Agility, we got over that first phase by using the older dynamic control systems like Brendan was describing Boston Dynamics using, but not everyone can do that. And secondarily, once you have done that, now it becomes a very real scaling problem with the deployment, so that you can then feed that back to get more of the cognitive style data that you really need to do things that are more useful. I would say, to say something positive, what this also means is you don't need to have a full set of representative data to do that initial deployment. And I think that's often talked about by some people in this space as being a hard requirement, i.e. we must have 1,000 hours of training data of people doing these tasks. I would argue, based on our experience, no you don't, but you will need that at some point as the system gains complexity.
Yeah, thanks. And one of the things we're doing at the ARM Institute, by the way, on this topic is because we are a public-private partnership with 460 members, hundreds of industrial members. The challenge on the data is industrial members don't want to share their data. They're very concerned about proprietary nature. So to amass the right size of a database is very hard. We got actually a government grant to create something we're calling the AI Data Foundry, where we're first working with our members across industry, academia, and government to develop the ideal way to create a data set that's not totally reliant on actual data. So using synthetic data, using other kinds of data, mapping a human being doing the task, and then modulating that back into electronic data. So first understanding with our membership, if you were to create the perfect methodology of creating a database that doesn't depend on millions and millions of repetitions, how would you do that? Secondly, we then go to our members and ask them to give us the data. We're a nonprofit, public-private partnership. We're a partner with the federal government. And so they trust us on anonymizing their data and using their data. So amassing data for a similar step like inspection or pick and place or something like that, developing a data set and then providing that back to the membership as a service. So I wouldn't say it's a huge project, but it's a project just to kind of take a step forward. And how do you utilize public-private partnerships to try to help create data sets when private companies are very challenged to do it themselves. So thanks for the comments on that. I'm going to shift gear a little bit to Brendan's area of expertise, and that's in the intersection of robotics and policy and regulatory issues. So Brendan, given your experience in those areas and your expertise, what regulatory or legal frameworks are needed to govern the safe and ethical deployment of intelligent robots in both public and private areas? And very importantly, what support do we in this industry need from the government in order to achieve those objectives?
Thank you. I think those are really important questions, and we often will talk about the potential negative impact of AI, of generative AI, when it comes to things like bias and misinformation and discrimination, et cetera. In the physical space, it's physical harm. So one of the principles we've had since we started selling our products, and there are others who join us in this ethics pledge, is not to weaponize the robot or allow it to be weaponized to harm people. And that's right in our terms and conditions of sale, and we're also working with state government officials, legislators in Massachusetts, California, and New York to legislate the general purpose robots, the kind that are used for commercial civilian operation, are not to be weaponized because, number one, that's unsafe. These are not systems tested for use with weapons. And number two, it really puts a cloud over the industry and a social acceptance challenge if people believe, like they saw in the movies and on Black Mirror, that the robots are coming to hurt people rather than to help them. So number one, we need to create ethical frameworks for the use of these systems in society, while also allowing legitimate use in the military and law enforcement domains, which I think are separately governed and typically outside the scope of these kinds of ethical frameworks or bills. Number two, to the second part of your question, really important, is that we need a national robotics strategy. So a lot of the work I've been doing the past year and a half has been to find folks here in Washington, up on the Hill, in the administration, try to establish and launch what I would call a national robotics strategy. Let's get together, industry and government, private-public partnerships, figure out what does this industry need to succeed, how do we deal with the subheading here, AI Expo for national competitiveness, what does the United States need to remain competitive in the robotics space, together with our allied countries, particularly with the emerging competitive threat that I mentioned. And we're starting to see traction. I see various committees on Capitol Hill, folks in the administration are saying, you know what, that's a good idea. We've seen a lot of output in terms of thought leadership, including from SCSP, that puts on this wonderful expo, saying, yes, we do need to engage and work on a national strategy. And that's what we would really love to see as a starting point to putting in place specific policies. Could be anything from tax incentives to workforce training to more partnerships like the ARM Institute to really lay a foundation for success.
Torsten or Damion?
I can maybe add from a technical perspective, when it comes to safety, if you look at the landscape of safety standards today, most of the standards are very outdated. Like, they were developed sometimes decades ago. And they were developed for, let's say, old school engineering methods. And I'm saying this respectfully. I'm not saying these are bad methods. These are great methods. However, these standards are not suited for today's AI methods. And so there's a need to update these safety standards to incorporate modern AI approaches. And ideally, this should not happen in the next 5 to 10 years. This should happen much sooner, so that the new technology that gets enabled through AI can be deployed in a safe way in the real world.
Yeah, I mean, I of course would not disagree with either of those views, and to maybe elaborate on a little bit, I think there is a view that it's going to take some time for the public to get aware of, that as we shift into a non-deterministic system, you have to be willing to accept a safety profile that looks a little bit more like the statistical argument that Torsten had mentioned, which I think we're used to, say, with aircraft, that the FAA has a testing regime that says you need to accumulate X number of hours on the airframe before it's viewed as safe. But I think what's maybe missed a little bit with that is that you have to be willing to identify that framework. And as Torsten was saying, that's very, very new. We don't have that framework for robots in general, much less mobile robots, much less robots with legs. That is something at Agility that we have actually our Chief Product Officer, Melanie, working on with A3 and other organizations. There is international focus on this, but to give you an idea maybe of the baseline, when we wanted to sell Digit for the first time 5 years ago, there was a single regulation we had to comply with, which was the FCC radiated emissions on the radio. And then if we wanted to ship it, we had to comply with 38.3 battery certification. That was it. So that's not a great starting point for a startup to look at how you're going to comply with a national regulatory scheme, because there simply wasn't one as of 5 years ago.
Yeah, thanks. I'm going to just add one thing to that from my own experiences. And this was an issue that was brought up to me by the Department of Defense itself, leadership in the DoD. Once a year, the institutes like ours that are partnered with the DoD get to go to the Pentagon, and we get to set up booths and demonstrate what we do. And of course, this was last year, so it was the previous administration, but a senior leader in DoD came up to me and asked for assistance from the Arm Institute to try to develop a narrative around what we do with respect to AI and robotics versus what's going on here in Washington, D.C. in terms of the debate and discussion about the social aspects of AI and generative AI and its effect on social media and deep fakes and so on. But that is not what we do. What we do is we advance the capability of robots to be more autonomous and more effective so that we can have a much more competitive manufacturing industry, so that the Department of Defense can actually meet its objectives to make all these assets that they're desperately far behind on. And without having more effective and more productive ways for robots to do that, the nation is going to be heavily challenged. In addition, for those of you that are manufacturers, if I asked you what's your #1 challenge today, it's probably lack of skilled workers. That is the most important issue in manufacturing. The organic industrial base is severely challenged. We have to have robots that are more autonomous, that are more intelligent to do the work that needs to be done for the Department of Defense, or it will never achieve its objectives. But what this DoD leader was saying is that that's getting caught up sort of in the narrative, in sort of the discussion about the challenges and the concerns, however legitimate, of AI in general. And the DoD, according to him, is getting challenged on getting the modernization done, because it's all kind of getting merged into the fear of deep fakes and things like that in social media. So I'll answer my own question. With the support that we need from the government is to somehow get the government to separate out what we're doing here. We're highly focused on the safety of these types of intelligent robots, but it is a different topic than the threats, the ethical and social threats, and some of the rhetoric that's going on here in Washington. So that's what we could use. We need those obstacles removed so we get the job done. One other thing I want to add, and maybe you have some experience and comments on this, because we're talking a lot about robots, and it's as if all the requirements is in that machine to somehow act safely around human beings and environment. There's lots of other technologies being developed that help that intelligent AI-driven robot be safe, things like light screens. So we had a demo, I don't know if any of you saw it, in our headquarters building in Pittsburgh, where we had a huge industrial Yaskawa robot, which was swinging around a big metal box and just swinging it around. And the demo was, if you went up to it, it immediately stopped and it dropped the box down. And the reason why is it wasn't the robot. There is a LiDAR-driven light screen developed by one of our members all over the room. So it's not just the robot and what people imagine, that robot, is it going to kill me or not, if it's going to step into me or not. You have lots of technology like that, including technology being developed where the light screen is actually projected by the robot, so it can actually be completely mobile, but it has this huge vision screen that's being developed from the robot. So there's lots of technologies that are being developed to ensure that it's not just the robot vision system in the machine, but the environment as well as being managed as a system. And that kind of brings me back to a third question, which I'll have for Damion. And Damion, talking about humanoid robots, they're having quite a moment, but they're also kind of shackled in some ways. And so how are you thinking about the role of legged robots in human-centric environments? What's needed to match up the capabilities of robots to the systems in order to make this whole aspect of robot mobility more robust and more scalable across more industries?
Yeah, this is a perennial debate that we've had inside Agility since the company was started. So when we first started commercializing our first robot, Cassie, which was actually a spin-off of a DARPA program, we were really looking at outdoor mobility as being one of the big distinguishing features of the robot. And legs are really good at that. There are other technologies that obviously you can use outdoors. UAVs are great if you're flying. Not obvious that they help a lot with ground transport. And then of course you can look at robots like the predecessor to Spot at Boston Dynamics, things that have legs that have a higher load capacity. So that's really what we were looking at for outdoor use. So why did we look at indoor ultimately? When we started looking at things like the safety issue, when we looked at customer ROI from an investment standpoint, indoor operations really solve a couple of problems. First is they make safety a problem like what was being discussed here, an access control issue. So it gives you the ability to sort of cheat, if you'd like to say, the safety problem. An example, it'd be very hard around my house to not step on something inside the house. And that thing could range from an 11-year-old to a Lego to something else. And that's bad, right? So if you have a robot in a home or a domestic environment or elder care or assisted living, having exposure to safety issues as part of the operating environment just makes a complicated problem even more complicated. So you can remove a lot of that by moving into an environment where the robot's only around trained operators, and then further where you have the ability to instrument the environment to impose safety that way. So with that in mind, then why would you want to use a humanoid as opposed to another technology platform? Our argument is that you should not use humanoids because they're cool. They are cool, but that's not the argument. It's if you have an environment that's engineered around the form factor of a person, or if you have a task that was really engineered around the form factor of a person. And we're not religious about this. It's not an argument for us that you should use humanoids for everything. If you asked me how would I move all of these chairs from, say, outside the auditorium to inside, I would say you put a humanoid on one end, you have a cart that's autonomous that you load the chairs onto, that drives in here, and then you unload. So a lot of the work that we're doing now, and this is all public stuff that we've done with GXO, with Amazon, and with Schaeffler, is really taking the form of doing humanoid robots, doing machine tending or other endpoint automation solutions where we have our robot interacting with other automation that does either high capacity or long distance transport. And that's really how I see the industry evolving. It's fascinating to look at the AGI side of the universe and ask where are these robots going to be 10 or 15 years from now. But from a practical, safe deployment standpoint, it's really robots working with other robots in the context of factory and warehouse automation is how we see the near term.
So Torsten or Brendan?
We as Intrinsic might be pure software companies, so we don't have hardware like my two peers have to offer. So the way we like to think of this is really from a customer's perspective. Like the embodiment or the form factor is a secondary question for us. As long, if it's a humanoid, that's great. There's nothing wrong with that. But if there's utility value for the customer, no matter whether it's a robot arm, two robot arms, let's say two robot arms and a head, be it on a passive base, on an active base, on legs, the customer use case is actually what the business case really is, what is determining what is best from an embodiment perspective. And the use cases that we are after at this point are mostly related to robot arms. So if you think of assembly tasks be it in electronics industry, automotive industry, just general industry, giving robot arms a sense of touch and a sense of vision, this is where we see like a sweet spot, like flexibility, low volume, high mix kind of use cases. And the embodiments are literally all over, but it depends on the use case coming from the customer.
Thanks. Brendan, you must have something to say on this. You've got all the videos. So.
Well, first of all, I'm looking forward to the robot that picks up the Legos and doesn't step on them. I think we could all use one of those at home, at least those of us with kids. Look, there's a lot of different challenges to building hardware, right? Hardware is hard, robotics is really hard. Reliability is a challenge, but also social acceptance and even industry acceptance. You know, what we see as a challenge is scale, right? So, you know, selling one or two spots or digits, it really isn't the goal. We really need fleets of robots out there, and that means that you need entire industries to be thinking of new ways of building or manufacturing or inspecting or mining or creating energy using these automation tools, including but not limited to robots. And to your demographics point, we need to do it because we don't have enough babies who will then become the workers of the future to do these honestly hard, dangerous, dull manual tasks. So how do we take existing industries and educate them on the benefits of the robots without necessarily being able to show them ROI within a short period of time, right? So if you can hit the sweet spot of like a year or two return on investment on the robot, you might be okay in certain industries, but other industries want the robot to pay for itself almost immediately, and that just doesn't exist at the kinds of price points that domestic manufacturers are creating. So again, to the competitiveness point, we're seeing foreign companies deploy the robots at scale in places where the economics are different and likely with government backing and support, and I think that's going to make a difference. And that's the challenge, is the culture and the deployment at scale.
Yeah, and it's going to demand different business models. If you have a whole scale of robots, whole fleets, whether it becomes an ownership or a rental that's maintained by the companies and so on, there's going to be a diversity of models versus I bought a robot and then have somebody come in and occasionally maintain it. So I'm going to close with the following question. This was Brendan's suggestion. I think it's very appropriate. I don't know if any of you sat in on the China and Innovation session at 1 o'clock, but I have to congratulate SCSP. I've been in technology for 43 years in semiconductors and now robotics, and there were some really excellent new insights that I didn't know about the Chinese innovation system. And of course, we're all tracking China for years. But let's close with talking about how we compare to the rest of the world, particularly China, in this whole topic of robots and AI. And maybe start with Torsten.
I mean, I think it's undeniable that there's a race going on and like various fronts. And I would say that's probably true for the hardware side of things, like Brendan mentioned, but it's also true for the software and AI side of things. We've all seen DeepSeek just as one example. And plus, if you look at just manufacturing, like a large amount of industrial robots are being deployed in China. The approach that Intrinsic is taking is really more focused on US and EU to start with. And this is also where we're looking for partnerships. And we also believe that looking at the needs of this part of the world, that there's an opportunity and a need, and we're hearing that actually loud and clear from our customers.
Thanks. Brendan?
Well, I've touched on this in a few of the answers I've given already. Look, and I agree, like we're definitely in yet another technological race. We've seen this in everything from social media, self-driving cars, the drone industry, and now it's robotics. And I think that's because China has recognized that in an environment where they can no longer pay people cents or a few dollars an hour to assemble things, and with birth rates that are still low, the only way to remain competitive in manufacturing all things is to automate the actual plants. And that's where we come up against some of those cultural issues here in terms of job displacement fears. So we really need to respond to that challenge, I think, by having government on our side, working on a national strategy, working in collaboration with the industry to really drive our own success, much in the way that we're seeing overseas. But it's not an unfamiliar story. I don't know that robotics is different from other hardware sectors where we see that emerging threat. And some of the policy levers are well known, and maybe others will need to be created that are different.
Damion?
So I think something that the U.S. has historically been very good at is leading quickly out of the gate. So we did that with space, we've done it with aviation, we did it clearly with robotics. Boston Dynamics was out long before the rest of the world, even other domestic players. My concern is we've created an incentive system through some of the way that we've handled, say, China policy to date that has prioritized low power consumption, low cost, and extremely rapid iteration. And when we look at what that industry has been able to do now over the last 18 to 24 months, it's legitimately very impressive. I don't think the US is behind, but we're playing one game, which is very high expense, high power consumption, high innovation, and we're competing against someone who might not be playing the same game. I've seen this in my house with having a Roborock now, which I do wonder if it's taking pictures of me. I was a fan of iRobot for a long time, and it's very hard to argue that the Chinese vacuum market hasn't completely trounced US players. Hopefully the same thing won't happen with larger robots, but we have to make sure we're fighting the right battle.
Yeah, thanks. And Brendan, I just want to add one thing to what you said about the national robotics strategy and policy. It has to be sustainable past every 4 years. One of the things China has, and I was in Singapore last year, and while I don't think either China or Singapore are beating us in innovation, I still think we lead the world in innovation in this topic. But in deployment, they're very advanced, and they have political reasons doing so. So we need a government policy. We need one to be long-term and sustainable and not be redone every 4 years. We are exactly out of time, and so I want to have you join me in thanking our panel for this policy.